You think you experience reality completely. 5 senses, working together, giving you the full picture. You don't. Every animal on this planet is living inside a richer sensory world than you are. And for most of human history, so were we. The evidence is now overwhelming. Your ancestors could detect magnetic north, feel the static charge in the air, and maybe even sense the emotional state of the people around them. Not metaphorically, literally. We didn't evolve to be the bluntest creatures on the planet. Something turned us down. Let's start with the one we know for sure we lost. In 2008, a team of researchers at the University of Massachusetts built a simple experiment. They took a group of students, blindfolded them, and let loose hundreds of newts in a wooden arena shaped like a figure 8. Newts, like many animals, have an instinct to walk in a specific magnetic direction. The researchers wanted to see if humans, with no training and no visual cues, would unconsciously align with the same field. When they removed the magnetic field entirely, the students walked in random patterns. When they turned it back on, the students' walking direction shifted. Slightly. Measurably. Nobody felt anything. Nobody knew anything was happening. But their bodies were responding to a magnetic field 50,000 times weaker than the Earth's. This experiment has been replicated. The effect is small, but it's real. The human brain contains a protein called cryptochrome, found in the retinas, that reacts to magnetic fields in exactly the way it does in birds. Birds use cryptochrome to navigate. We have it. We just don't use it the same way. Think about what that means. We didn't evolve the machinery for magnetoreception. We inherited it. It came from a common ancestor we share with birds, with reptiles, with insects. The system is in there. It works. Something just turned the volume down. But here's what's fascinating. Magnetoreception might be the most boring sense we lost. In 2011, a woman walked into a neurology clinic in Germany. She was in her late 30s, no history of psychiatric conditions, no reported brain injury. She was there because of something she couldn't explain. Every time she sat near a working electrical outlet, she felt a faint tingle in her fingertips. Not pain, not numbness, just presence. Like the outlet was whispering to her skin. Her doctors did the standard workup. Nothing. So they scanned her brain. What they found surprised everyone. Activity in regions of the somatosensory cortex that in 99% of humans are completely silent. Her brain was processing electrical fields, tiny ones, the kind emitted by household wiring. The research team that published her case in 2013 didn't call it a superpower. They called it something more interesting. A remnant. A piece of ancestral hardware firing up in a brain that, statistically, shouldn't have access to it anymore. Other animals process electrical fields constantly. Sharks can detect the heartbeat of a fish buried under sand. Platypuses use electroreception to hunt in muddy water so cloudy they can't see. Bees sense the static charge that builds up on flowers and use it to tell which ones have already been visited by other bees. The information is there, they just live in it. And here's the part nobody talks about. Our closest evolutionary cousins do too. Chimpanzees have been observed responding to subtle changes in atmospheric electricity before storms. Macaques show measurable changes in skin conductance during social interactions, changes that begin milliseconds before any visible cue is given. We don't know what they're sensing. We know it's happening. The honest answer is that we don't know what we lost. We know some of it. The cryptochrome is real. The magnetoreception experiments have been replicated. The case studies of humans with anomalous electrical sensitivity keep appearing in the literature. But the bigger question, whether our ancestors experienced a richer sensory world than we do, is one science is only beginning to ask. What we do know is that the trade wasn't random. Senses don't disappear because evolution forgets. They disappear because something else takes their place. And in the human lineage, that something else was vision. Here's the part almost nobody talks about. The human eye is the most metabolically expensive organ in the body. Your brain devotes roughly a third of its total processing power to interpreting visual information. That comes at a cost. Every neural system needs resources, and there's only so much to go around. As our ancestors' visual systems expanded, sharper color vision, better depth perception, the ability to read faces and track movement across open savannas, other sensory systems got less investment. The same thing happened to the rest of the great apes. They have weaker senses of smell than their ancestors. They lost some color vision. They rely, like us, on a brain that built itself around seeing. The blindness to other senses isn't a human flaw, it's a primate compromise. But here's the strangest part. The loss might not be permanent. In 2019, a research team in Japan ran an experiment that shouldn't have worked. They exposed human participants to rotating magnetic fields for several weeks, and then asked them to perform a simple magnetic direction test. The participants' accuracy improved, slightly, measurably. They weren't born with magnetoreception. They were learning it. Their brains, given the right input, were retuning the old system. The implications are uncomfortable. It suggests the human brain isn't missing anything. It's just dormant. A radio that knows the station is there, but the dial was turned so far down no one thought to look for the frequency. We didn't evolve to be the bluntest creatures on the planet. We evolved to be the most specialized. We built a world around vision, around language, around the manipulation of tools and symbols, and in exchange, we let other channels go quiet. But they didn't go away. Somewhere in your brain right now, cryptochrome is sitting in your retinas. Electrosensitive neurons are sitting in your cortex. A whole system for processing the invisible world is sitting there, dimmed but not deleted. You think you experience reality completely. You don't. You experience the slice of it your brain has prioritized, and the rest is still there, waiting, the way an old song waits in the back of your mind for someone to hum the first note. For most of human history, your ancestors were listening to it, and then, slowly, they stopped. Not because they lost the ability, because they found something louder, and we never went back to find out what the quiet was saying.